Hi everyone, welcome back to the channel. In today's video, we'll be diving deep into client-side Solana transaction encoding. Before we start, if you learned something new today and find value in this presentation, I'd greatly appreciate it if you could like this video, subscribe to the channel, and hit the notification bell so that other people can find this content. Hopefully, it will be useful to them as well. So, with that out of the way, we'll kick things off with a quick mobile app demo to review the scenario we will be working on today, which is basically around fetching and creating user profiles with the DApp. And that, it's a very common use case for DApps in general. And I think it's a very practical example of how to encode transactions for Solana, for working with Solana. After that, we'll break down the Borsh encoding, which is obviously essential if you want to work with Solana transactions for your DApp development. Next, we'll walk you through the code for two common DApp operations, which is effectively a simple read and write operation in the context of this fetch and create. So obviously the fetch will be the read, the create will be the write operation in the blockchain. And then we'll have a detailed look at how to encode this transaction that will be sent to the Phantom wallet via deep links. Now, in my app, as I've mentioned in previous videos, I've used two methods of integrating with the Phantom wallet because obviously I'm targeting web and mobile. With mobile, I've gone with deep links as the kind of the primary integration mechanism. For web, I have interfaced directly with the browser, the Phantom browser extension, and it's a little bit more direct. It's less convoluted, sort of the way that the integration works. So today, because in previous videos I've talked a lot about the web side of things, today I'll be talking a little bit more about the mobile side of things. But at any point in time, if you guys want a little bit of a more of a deep dive on the web and how that integration works, I'm more than happy to cover that. And specifically, in the context of transaction encoding for the web, it's very, very similar to what I'm going to show you today. The steps are kind of more or less the same, but there are a few differences when it comes to the web that I can show you exactly if there is sufficient interest from your side on how that works. So yeah, so by the end of this video, you'll have like a solid understanding of how to encode Solana transactions using Dart in this case for both read and write operations. But I think this is even useful, even if you're not using Dart, if you're using JavaScript as your primary client-side programming language, or any other language, it doesn't matter which language. What you'll get from this video is the general steps that you need to be aware of when encoding transactions. And even if the syntax is different in your programming language, kind of the methods and the mechanisms are kind of similar. In JavaScript, it might even, I'm pretty sure it's even easier than what I have here for Dart. But for other non-JavaScript programming languages, it might be actually as, it will be very, very similar steps, let's put it like that, compared to Dart. So let's go to, sorry, clicking the wrong button, to the mobile app then. So let me locate the app first and switch to the mobile app. All right, so as you can see, I've already launched the app in the emulator so that we don't waste any more time. And as you can see here, this is, so after the wallet select, so when you install the app for the first time, the first screen you'll see is not this one, is one where it will ask you which wallet you want to use. I've only implemented really Phantom so far, so I've skipped that step straight into this one. And now when you click on this, it will ask you to connect. I click connect. And as you can see here, the first thing you see is this create account button. Now, if you had already created your account, you wouldn't see this, you would see the products page straight away. So when I click create account, there will be a very, very tiny, a few pennies worth sold that is taken from my wallet to create that account. I click confirm, and now you can see the products, right? So I'm now in the so-called home page. So if I disconnect, I come back to the sign in screen. And if I now sign in again and connect, you'll see that I no longer see that create account button because it already detects that I already have done that step. How does it do that? Well, it fetches the user profile first. And if it finds a profile for my wallet, then it doesn't have to create the account anymore because it's already been created. However, if it's the first time, then it has to go through that process that you've seen earlier to create the account. So that's all I wanted to show you for the time being for the mobile app. So let's go back to the slides so we can continue with our presentation. All right, so let's talk about Borsh encoding, which is, as I said before, very, very essential if you're serious about doing transactions with Solana. So Borsh encoding is like a fast and efficient binary serialization format. And it's a little bit like, for those of you that are familiar with protocol buffers, then it's a bit like that. It's a binary encoding format, which is very efficient, very streamlined, very space efficient as well. But it's Borsh is more tailored for use with blockchains. It's a little bit less complex than protobuf, and it's more sort of specific, and it's less general purpose. Let's put it like that. Borsh is also deterministic. And what I mean by that is that the output byte sequence depends on, if what you feed it is the same sort of data, then it always produces the same byte sequence as a result of that. But the important thing is that the order of the fields in your class that you're serializing affects obviously the output. So consistency between our client data objects and the contract data objects is crucial, that consistency exists from both sides. As I said here on the slide, changing the field order in your class will change the serialized output. So make sure that both client and contract code are consistent. So this is a representation of a customer object or class struct, depending on the programming language that you're using. But let's use the class for now because we're talking about Dart. So in Dart, you have this object. I defined the user profile received class, and this one actually matches the class that what I mean to do here is this matches the class that is also defined in the smart contract in the Solana program. So there is a customer struct there that exactly matches this one. We'll see this in a minute, in the next few slides. But effectively, you use this Borsh annotation package, And when you're defining your class, you use annotations like the Borsh serializable that you see here to mark the class that will be sort of serialized, and the fields in the class are annotated with the appropriate types like this bfixed array or bstring. So these types are basically defined in this file that you see here. So this file, user profile received.g.dart, is automatically generated. Again, we'll talk about this in the next slide, but just remember this one for the next slide. And this is all part of the Borsh package that we're going to import into our project. So let's talk about that. So, we'll have obviously, so for this reference to the .g.dart file that we discussed in the previous slide is going to be automatically generated, as I said, and that is basically generated by the build runner. And for this build runner to work, like for this whole thing to work, you need three Borsh packages in your project. Two libraries for Borsh. So you have Borsh and Borsh annotation. So these two need to be imported, and they will be part of your YAML file, your pubspec YAML file. And then you'll have your build runner one that you see here, which is under dev dependencies. So you can see here this build runner one. So this is necessary. And once you have these, then you can start running this command that you see here. So flutter pub run build runner build delete conflicting outputs verbose. I use this because previously I was having a few issues with the build runner. But once I started using these attributes, I never looked back, and I always use these. But when it succeeds, it doesn't generate too much output anyway in the console. So you have these two alternatives. You either run this. I typically run this first one when I need to, but so essentially, anytime that I make a change to that file, to this file here, so so if I made any change to these class definitions on this, so this is one. I have several of these classes. Some of them were a lot more complicated. So this is one of the easiest, simplest ones. I wanted to start with a simple example, but in my next video, I'll show you some of the more complex ones with even some types that are not supported directly by Borsh, but you can extend this to have those types supported as well, and I'll show that in an upcoming video. But the key point here is that whenever you make changes to those files, you need to run this again so that it automatically updates the code generated sort of .g.dart file, which includes one of the things I actually forgot to mention about here is, so there is this from Borsh method, which, as you can see from this definition here, it allows the deserialization of binary data, which is basically this one that you see here, uint list, and received. This is the data that you receive from Solana, and it turns this into an object of this type. So as you can imagine, when you query the blockchain returns that binary serialized data, and you want to convert that binary data into this data in runtime so that you can read the contents of that data. And there is also one that it's not shown here in the screenshot, but there is also one that is the to Borsh, as you can imagine. And that is defined in this .g.dart file. And as you can imagine, that is used when you want to send data to the blockchain. So this is obviously useful when you receive data from the blockchain and you want to interpret the data. And then there is the to Borsh one, which basically takes your data objects at runtime, serializes them into that binary super optimized format, and then basically that is used to construct the instruction, which is then packaged into a transaction, and then that transaction is sent over to Solana. So that's that. What else? Do I want to say anything more from my notes here? Yeah, so for the time being, I think that's it. Let's move on. So, fetching and creating a user profile. So, as I stated in one of my previous videos about DApp architecture, so this was one of the earlier videos, I mentioned that I created two entities in this Flutter application. One is the blockchain and the other one is the wallet. The transactions that are mainly read-only, they go through the blockchain component, but if they require any user approval, they go through the wallet component. Mainly, any transactions which affect the user funds, of course, need their approval, but also a simple connect, because obviously to connect you need the user approval or consent. All right, so let's talk about the fetch user profile. So fetch, if you recall back in the application, in the mobile app demo that I've done initially, you remember that you saw that create button, that create account button. Now, this fetch function is called, is one of the first to be called. So as I say here, first we connect to the wallet. This is basically a signing, and there is really no blockchain transaction behind this action. This is just a simple wallet interaction to log in the user. So as long as they have the Phantom wallet installed, either on their mobile phone or in the browser, then we obviously can connect to that wallet. Obviously, they'll get that prompt saying, do you allow the connect? We click yes, and then we are connected. On a successful connect, we get the user public key from their wallet, as we discussed in previous videos. With that public key, we can now search, obviously, the blockchain for the user account, or let's say the user profile. This is a read-only operation. So it goes via our blockchain component, as it does not require user approval to proceed. This user profile is a very simple object, in this case, for this particular application. For your application, it might be actually quite a big object, but in this application, it is just a simple data structure which only contains the wallet address of the user that owns that user profile, which is basically the public key that is their wallet's public key, and the shipping details encrypted, which will continue in an empty state until there is an actual purchase order, which is placed later on as the user interacts with the application. So, as you can imagine, being an e-commerce platform, if the user buys a bottle of wine or a bunch of bottles of wine, I need an address to send those bottles of wine to. So, but I don't need to collect that address straight away. I can collect the address. I can collect the address only at the point where they place the order. We don't need to be intrusive in that sense. So it's also if you can imagine, it's a best practice. Many applications nowadays do this. When you register for a new account, they don't ask you. They could ask you for all the information, in which case it would be a very tedious a very bad user experience. I for one, and I don't think there is anyone that likes doing this. Like if you get asked 40 different questions, that is like super tedious, and a lot of people just basically give up and they go somewhere else. But if you only get asked a couple of questions, you're quite happy to answer those questions, and as you become a more power user of the application and you want to use more features, the application asks you for the additional information required to operate those features as and when needed. So it doesn't force that information from you straight away. You might even not want to use those features. So it's a best practice. So anyway, so as you've seen, this user profile only has these two fields. One is an encrypted field, which is the shipping details field, and the other one is the wallet public key, which basically is the owner of the user profile. So let's talk a little bit about this function that we see here in front of us, which is the fetch user profile. So so the first thing to note is that is this comment that I've put in here. So these seeds, if you can remember, these seeds they come actually, this notation that you see here comes from the Rust Solana program, and I've copied and pasted these from that file, from the other file where I have the smart contract that this client is interfacing with or calling. And I put it in here just so we guide ourselves on how the seeds, because the way the client generates the program derived address, and I'm not going to go into the details of what a PDA is. I've spoken about that in one of my previous videos. Please go watch one of the earlier ones where PDAs are the topic of discussion. But it essentially the one-line summary is the program is going to generate an address for you where your profile is going to be stored. So in Solana, everything is an account, and you will have a Solana account to store your profile data, which is those two fields as we just discussed. So we start off by creating the public key objects associated with the user public key, with the administrator public key, and with the program ID key as well. So these two, so obviously the first one was returned from the connect action when we connect to the wallet, and the other two are defined, embedded in the code of the app. So the administrator public key is embedded in the app, and the program ID is also embedded in the app. So the app knows about these two. So they are kind of string constants, let's put it like that. And as we can see here, this step here is basically defining what the user profile PDA is going to be. So it basically uses this. The first one is a customer seed string, which is converted into bytes. Then you have the administrator key, which is that one there, turned into a byte sequence. And the same thing goes for the user public key, which is turned into a byte sequence. So these seeds are then joined with the program ID, which we have there. And then the combination of all of these things are used to generate a user profile PDA, program derived address. Now, this is not, so this is basically, the search didn't happen yet. This is basically me just saying, okay, what's the PDA when we use these seeds? Oh, okay, and I'm using the same formula, the same seed formula as my smart contract, as you see here. So now that I have that, I can go and call the RPC client, the Solana RPC client, get account info. So that RPC method, what does it need? it needs three things. It needs the user profile PDA, which is basically there. It's the one that I just generated, but in base 58, so it converts it back to a string. Then I'm saying the commitment status is confirmed, so it's basically a confirmed account already, and the encoding is base 64. So this is a little bit yeah. So these are the three things that you need. Now, when this returns the data, obviously it might not find anything. So if the user profile has not been created yet, then obviously this will return null. But if it does return something and it's different from null, then it's likely that the user profile is already created. So let's interpret this element here. So one sort of key technical detail to understand when deserializing the binary account info that is returned is that you need to be stripping the first 8 bytes before deserializing the rest of the data using Borsh. So this is because the first 8 bytes are used to identify the account type, not the actual account data itself. So after removing this sort of discriminator that exists as the first 8 bytes, the remaining bytes correspond to the actual data that is basically the serialized data structure, which you now can deserialize using this from Borsh that we talked about earlier on. And now you have your user profile, and you can return that user profile. This, obviously, by the way, and this is what I was looking for initially, and then I forgot that I only had it here. This matches the definition of the customer struct in my Solana program. So this is the Rust code, so that you can compare with the one that we had before defined in the Flutter in the Dart code with the Borsh serializable annotations and all that. But it matches exactly this. There is the first field is a public key. The second field is a shipping details encrypted. It's a string. And as you can see, the order is the same. Please don't forget that. I had some initial issues with this where the order of the fields was not the same, and this was creating all sorts of problems. So absolutely make sure that your client definitions match your smart contract definitions in terms of the order, because otherwise it's going to be a recipe for lots of issues, lots of time wasted. Make sure that you're clean on these basic hygiene factors, let's put it like that. The other aspect that I spent so much time, I spent countless hours on this, was this figuring out, like, this is not mentioned explicitly. At least when I read the Solana documentation and all of these things, I didn't find this exact. And maybe the reason for this is because the JavaScript libraries abstract a lot of this. So when you're using JavaScript, I suspect you probably don't need to know all of these things. But when you're using something other than JavaScript, you might be facing challenges like this one that I'm just talking about. So it took me a while to figure, like, when I was trying to deserialize the account data, I was getting like funny, sometimes it would crash when using the deserialization with Borsh. Other times it would succeed, but the data looked wrong. And the reason it would look wrong was because it was not stripping the first 8 bytes. So it was starting at position 0 and then trying to read the user profile from there. And obviously that was completely wrong, because the first 8 bytes should be discarded, because that's that discriminator that I talked about, which is basically the account type. So yeah, lost a lot of time with this, but hopefully now you don't have to waste that time, because I did waste mine on this. So let's continue. So this is fetch. So what if the user, the profile is not being created? As I've shown in the mobile app in the beginning, you know, the button, the create profile button was kind of shown there. So let's examine this code then. What is it doing? So the first thing, so this first section of the code here, I kind of suspect that I probably don't need this long term. Maybe I overcomplicate it a little bit. I was basically going belts and braces on this, and to be honest with you, initially when I did this, I thought it was required. And so I've not made up my mind yet whether I'm going to remove this or not. Obviously, these don't pay attention to all the prints that you see here on the code spread all over the place because I'm still in development mode. When this application goes to production, a lot of these prints will not be there. There will be other forms of logging that will be obviously more useful for applications that are in production. You'll see a lot of to-do comments all over the place because I've not finished this application, obviously. And this is just reminders to myself that I need to do these things. But the point that I'm trying to make here is that I'm trying to see whether the user has enough balance. So in this case, 0.01 Sol in their wallet in order to proceed with the create user profile account. Because obviously if they have like 0 Sol, this wouldn't work. Now, the reason I say this might be a little bit redundant is, of course, that there is a pre-flight check that I'll show you at the later in the next slide or two, where the transaction is actually simulated, and if the user, for instance, doesn't have sufficient funds in their wallet, then that will fail anyway. So that makes basically this check, like this manual check that I'm doing here, it's probably redundant in that sense, because there is that pre-flight check. Now, we could disable that check, but in our case, I think it's pretty useful that that is there. But let's talk about that later on. We're going off in a little bit in a tangent. After checking whether there is enough balance to create the user profile, again, the same step, I basically create the objects for the public keys, for the user public key, for the admin, and for the program ID. This is our program ID. This is where the smart contract lives. This is the address of the smart contract or the Solana program using Solana terminology. I just prefer smart contract. I find it, as I said, cooler. The Ethereum terminology is in this case, I think it's nicer. Now we have seeds here. So this is basically the same thing. So what we're doing, this step is identical to the fetch. So we are generating the user profile PDA, as you can see here. So the user profile PDA is generated. But we don't stop there. Now we are going to say, okay, to create the user profile, we also need the admin PDA, right? So this program initially, when it launches, one of the things I will have to do with it is create the admin account for that program. So this is that seed is the seed that is being used in the smart contract to do that. And that's what I am emulating here on the client side to generate the exact same address. So from the same seeds, the address is deterministic and we can generate it. So I generated the admin profile PDA. Next, because this is going to be calling the instruction which is add customer, we have the add customer method. And this add customer is basically this add customer that you see here in the smart contract. So this is the Rust code, right? So I'm showing you the counterpart. So this is the client that is going to be calling this instruction which is part of the Solana smart contract. And as you would notice the name, add underscore customer, which is exactly the same name that I have here, right? So I'm effectively calling this add customer. Then you see this add discriminator. What is this add discriminator? I'm glad you asked. Here is the add discriminator. So basically it takes a namespace in the method. So the namespace is global. The method is add customer. I haven't figured out like all the different namespaces yet. My research didn't go that far yet, so don't even bother asking because I don't know the answer to that. But effectively, I know that for our custom methods, at least I did, this is where my methods are basically residing in the global namespace. So that's what I'm using here. And as you can see, this function is very simple. What it does is it concatenates with a colon the namespace and the method. So it's global colon add customer, and then it basically hashes that with this SHA-256. So it hashes that string and it turns it into a byte sequence, and then it basically returns the first 8 bytes of that sequence. And this is basically what is going to tell the Solana blockchain that this is the method that I want to call, or this is the instruction, to be more precise with the terminology. This is the Solana instruction of the Solana program that I want to call. Hopefully that's made sense. Next, we encode the data. That remember that add customer receives the two arguments, which basically are the two fields of that customer struct. So it receives the customer wallet and the shipping address details, even though at first the shipping address details are an empty string. As you can see here, so this is the wallet address being popped. So we create a new object where we say the wallet address is the user public key bytes. So it's the bytes corresponding to that user public key. And then the shipping details in this case are empty because we've not got to the stage of interaction with the app where this is required. So it's basically saved as an empty string to start with. And then we call the toBorsh. You remember that I mentioned this before. So this is inside of that .g.dart file, which is automatically generated by the build runner, the Borsh build runner, as we discussed. So this is basically, I call in this user data object, I call the toBorsh, and that basically gets me the user data bytes. And now the method data is basically the concatenation of the bytes of the discriminator, the first 8 bytes of the hash of that string, which is global colon add underscore customer, if you remember that, plus the user data bytes, which is what we just calculated. And then, so this effectively, this is now very clearly saying, call this instruction with this payload. That's exactly like, this is the byte encoded sort of call this instruction with this payload. Now we convert, so the object that we're going to use for to create an instruction uses a different object type for the public keys, which is the Solana Web3 pub key. So I had to convert my previous pub key object into this pub key object, which is compatible with the Solana Web3 instruction. And I did it with all the pub keys, not just that one. So as you can see, we're now finally at the point where we are building the instruction. And what is the instruction? So the instruction is very simple. It has an array of keys, or let's call them accounts, where you specify for each of them whether they are a signer account, so whether they will need to sign the transaction or not, and whether the account is going to be just for reading or for writing also as well. So if you, the important concept of the Solana programs and instructions in general is that for an instruction to work, and I mentioned this in one of my earlier videos, for an instruction to work, it needs to have all the accounts that is going to be operating on passed in as arguments. So, and those accounts will be, some will be read from, some will be written to, and some will be read and written to. So, and this is what's happening here, right? So let me just show you side-by-side comparison. So this is the Rust code that basically represents the add customer context. And if you remember when I shown you earlier on the Solana add customer instruction, it had 3 arguments in there. One was the context. The context is this. And then there was the other 2 fields, which is basically what we are passing on the customer public key and the shipping details encrypted, which is going to be empty at first. So if you compare this with this, you'll see that it's identical. Let's go side-by-side comparison. So the first one is the signer, which is this one here, right? So as you can see, I'm saying the user public key is the first one. We are going to require that the user signs the transaction, and it's writable. Why? Because this transaction to create the account is going to affect the user's funds, so therefore it's writable. So as you can see, it's this first one. Second one, admin profile. See what we're creating here in the second one? So we are generating the admin profile. And this is the C's that you saw earlier in the comment in the code that you saw earlier. So as you can see, we're saying it's writable, of course, because the admin is going to, in the instruction itself, we are going to modify some statistical data inside the admin account, like number of customers and things like that. So that is the reason why it's writable, but it's not a signer. So we are not requesting the admin to sign the transaction. Only the customer needs to sign, or the user needs to sign the transaction. Next one, we see user profile pub key, which is effectively, this is the most important one, which is this is the actual creation of the user profile account in the Solana instruction. Again, you might remember this. This is the way the user profile PDA is created with this sequence of seeds. And of course, as you can imagine, the user profile PDA is writable because it's been created, so it has to be writable. But it's not a signer. No, of course not. So the only signer, again, is the user. So it's false there. But there are some instructions where you could require multiple signatures. It's not in scope for this video today, but that's why we need, for each account, we need to specify whether that account is also going to be a signer or not. And finally, we have the system program pub key, which is effectively matching this one here in the Rust code. So as you can see, there is like a really good, and when I was developing the Dart code, like the client-side code, I often had like the side-by-side, like I had on the left side, I had my Dart code, and on the right side, I had my Rust code. And obviously I developed the Rust code first, so always start with the server side. That's what I find useful. Start with the server side, And now then I started developing the client side after having the server side done. And I found it really useful. It's a good tip for you as well to have the two code bases side by side, because when I was building these keys, I was like comparing 1, 2, 3, 4, say, okay, I didn't forget anything. Because if you forget to say that I forgot to put this one here, the call to the instruction would fail. And the errors that you get are not immediately obvious why it's failing. It just says that it fails. So that's why I always highly encourage you to do what I'm doing now. And the other important aspects of this instruction, so you see it's an array of accounts, which is the context of the Solana instruction that you're calling, apart from the payload that we already discussed, the user public key and the shipping details encrypted. But we also have these other two, which are obviously super important. The program ID, so this is our program ID, our smart contract. So this is the address. So that address, in my case, it's embedded within the client-side code. And then you have the method data. And if you remember, the method data is again the 8-byte discriminator plus the Borsh serialized payload that is required for the Solana instruction. So the two things are combined, and therefore you have the method data. So there you go. So you have this instruction object effectively contains everything that is required for sending the Solana instruction to the blockchain. So this is the final element here. So we get the recent block hash from the blockchain via the RPC. So the blockchain is an object, as I mentioned before, that I created, which interfaces directly with the Solana RPC to get the block hash, and we create a transaction. So a transaction, just to refresh your memories, I mentioned this in one of my previous videos. A transaction is comprised of one or more instructions. And if either the transaction succeeds if all instructions succeed, and it fails if at least one of the instructions fail. It's similar to how transactional databases actually work. And as you can see here, I am basically serializing the transaction by using this this configuration parameter that basically says that I don't require all signatures to be there, so it's only the user that needs to sign. I never actually tried to put this to true to see what would happen, but never mind that. And so after serializing the transaction object, which inside of it is the instruction that we just discussed, we have to base 58 encoded as per the Phantom documentation, and then I call this sign in send transaction. So sign in send transaction is one of the functions that I've defined. So I'm going to discuss that in the next slide as the last element of this presentation today, which is already running a little bit long. So, but before we go to the next slide, I just wanted to talk briefly about this recent block hash, which is interesting. So the recent block hash is used to tie the transaction to a specific recent state of the blockchain, ensuring that, number one, the transaction cannot be replayed. So there are replay attacks, so people could use the same transaction over and over to replay. So this is basically, if they use the same block hash, it will be just rejected by the blockchain. the transaction is only valid for a limited period of time. The transaction, this block hash. So block hashes expire after a short period of time. I don't quote me on this, but from what I've read, it's typically around 150 to 200 slots, so or around equivalent to 1 or 2 minutes. So this is very short-lived. So again, this ensures that if a transaction is using a very old block hash, it will be discarded by the blockchain because it's likely irrelevant. So validators can quickly basically verify that the transaction is no longer relevant to be processed, and it will fail. And then people will have to retry the transaction again. But yeah, I just wanted to mention what that recent block hash is. Yeah, and then obviously if the sign and send transaction returns an error, then I notify. Again, I need to do some further work here, but that's a very basic error handling there. So let's talk about the sign and send transaction. So that one that you saw there. So the first thing to note is that there is this send options here. Which I think it's very important to understand. Now, this whole object is optional, so you don't have to really define it. But I decided to define it to force myself to make sure that I understand the defaults, even though these values here, most of them are default values, but I wanted to define them to force myself to understand what they mean. So let's go one by one to explain what these are. So the first one is the max retries one. So this is the maximum number of times that for the RPC node to retry sending a transaction to the blockchain. So I think it's pretty self-explanatory. I'm not going to spend more time on this. I've set it to 0, so that means that it tries to send it once. If it failed, it doesn't try again. Skip pre-flight. So this one is it means basically whether we should disable transaction verification steps. So this check simulates the transaction to ensure that it will succeed, meaning that it verifies if the transaction is well formed. It checks for issues like, for example, insufficient funds, missing signatures, or invalid instructions. And as you can imagine, this can help catch errors before transactions are processed by a validator, saving time, resources, and money. Because obviously, if it's going to fail, why bother sending a transaction, even wasting users' funds? And this is the reason. So this skip pre-flight is the thing that got me thinking about. You remember when I was talking about earlier about whether that check about whether the user had sufficient balance in their wallet when creating the user profile. I was checking whether the user had like 0.01 Sol in their wallet. And this is the thing that got me thinking, hold on a second, do I really need to do this? Because later on, if I set this skip pre-flight to false, that means that I'm not going to disable the transaction simulation step, so it will happen. And if the user has 0 on their wallet, the simulation will fail, and therefore the user will be notified that they need some funds in order to proceed. Now, the only reason I think it might be useful to have a check of our own is if we want to make the user experience better, because before we even get to this step, I can already tell that they don't have enough funds in the wallet, and therefore I can just give them a nice error message, a friendly error message, a pop-up in the app saying, please load some Sol into your wallet so that we can proceed with creating your user profile, otherwise it's not going to work. So it could be that the message that the wallet gives them, if I don't have that user-friendly thing, it could be that when it gets to this step, yes, it will fail, it won't, nothing bad will happen, but it's just that the user experience might be slightly worse. I don't know if the messaging from the Phantom wallet itself will be sufficiently user-friendly so that they understand what's happening. It should be okay, but I actually didn't test that. I could actually disable, comment out that my portion and try with a brand new wallet that has 0 funds in there and see what happens. That's actually a good test for me to try. I'll let you know what happens. So yeah, so this is a really, the skip pre-flight, always set it to false because you want the simulation to happen. And then finally, we have the all-important pre-flight commitment. And this is a way of telling the wallet what level of confirmation we expect to get from the blockchain before it tells us whether the transaction succeeded or failed. These are different values, like there are different values that you can have as part of this. So let's talk about the 3 main values. So the first one is processed. So this here, so this pre-flight commitment, which you see I've set it to confirmed, so it can have the processed value. So when it has processed, basically what that means is that the transaction has been processed by a node but might be rolled back. If the lowest, this is the lowest level of commitment and does not guarantee that the transaction will be finalized. It provides the fastest response, but it's not guaranteed to be permanent. You should use this when you need to have like some quick feedback, but you are okay with the risk of the transaction being reverted. So I wouldn't suggest you kind of use this. Like for the most part, you typically don't want this commitment. So let's go to the next one, which is confirmed, and this is the really important one. So the transaction, in this case, what does confirmed mean? So the transaction has been included in a block that has been voted on by a supermajority of validators. And supermajority in this case means about typically more than 66% of the validators have confirmed, making it sort of more reliable, way more reliable than just processed. But there is still a chance that it could be rolled back if the cluster is reorganized. Now, what does that mean effectively? So the blockchain might temporarily fork or diverge where multiple versions of the chain exist. The network then needs to decide which chain is the valid one. If a chain with a more support, like a supermajority of validators, appears, the blockchain might discard the previous chain and adopt the new one, potentially rolling back some transactions in the process. It provides, so this is how like a confirmed transaction might still be reverted in scenarios like this. But you know, these should be rare. It shouldn't happen too often. And it provides, you know, so this confirmed, it provides kind of a middle ground between speed and finality. And this is like a common choice for most wallet applications. So this is one that I'm also using here in the application. And finally, the final sort of value for this pre-flight commitment is called finalized. As you can imagine, this is the highest level of commitment. The transaction has been voted on and confirmed by a supermajority of the cluster and is included in the root. So this is guaranteed to be permanent and immutable. So let's do a summary. Process means fast, but it's risky. The transaction might be reverted. Confirmed means it's more reliable, voted by a supermajority, but it still has the possibility to be rolled back in those situations that I've mentioned earlier. And then finally, there is the finalized. which is most secure but takes longer to get that confirmation, but it's guaranteed to be permanent. It's like immutable, it's stored in the blockchain, it's not gonna be reverted. So that's that. Now we have this, so we've set those options. Let's skip this for now because this element here that you see is for the web. So I can talk about this some other time if you wish, but I'm going to skip this block here. And then you finally have this payload to encrypt. So we encode the payload that is going to be sent to Phantom via deep link. By the way, I found that all of this is required from the Phantom documentation. I'll put a link down below in the video description, of course. I had this link even before in one of my previous videos, but I'll put it again in the video description. But again, so as you can see, the transaction, so the serialized transaction is what we received in the argument. Then the send options, which is the ones that we just discussed, and then finally the session. Now the session is it's basically returned to us after we connect to the Phantom wallet, and it should be used in every subsequent sort of interaction with Phantom. We should always send this session, so we should save this session value, the string, when we get this returned from the connection interaction with the wallet. Yeah, so that's that. So next one is, yeah, so when we send information via deep links, it's always the best practice to encrypt this information. And this is obviously not surprising that Phantom requests us to do that as well. And so I call this encrypt data function that I've defined again because we don't have much time here. I'm not going to go into the nitty-gritty detail about how this function works. But again, if you want me to have a session, maybe a subsequent video, or if you want me to apply on some of the comment sections, please let me know if this is a problem for you. It should be fairly straightforward, but what we are doing here is we pass into this encrypt data the DApp private key. So this is generated basically at runtime when the app launches for the first time, and we basically keep it in secure storage. There are no private keys embedded in the app code. This is obviously goes without saying. It's a big security flaw or issue if you obviously have private keys in the code. The Phantom public key is basically returned to us after the connect to Phantom. So the session is returned, but also the Phantom public key. And what else? Yeah, the payload to encrypt, which we already discussed. I think that's it really, because yeah, so this is how you call the sign and send transaction in Phantom. You then pass it on the DApp public key. So this was generated, of course, as part of launching the app for the first time. Then the encrypted payload nonce is sent so that they can decrypt the data package that is encrypted. You send the redirect link. So this is going to be your app scheme that is registered. I had a video about this, like talking about the nitty-gritty detail of setting this up in iOS and Android, and it's painful and it's different. Each platform has its own different things that you need to be aware of. And there is a whole video about this, how to set this up and configure this. So please check that out if you're interested on how to do this. And then you have your payload. Yeah, so this is the payload that is going to be sent as part of the transaction. So I think these are, again, all of these are properly detailed and explained in the Phantom documentation. And this is, again, I'll put the link in the video description. And yeah, so this, again, in one of my previous videos, that I talk about these like these libraries, these Dart libraries, these Flutter Dart libraries to use with deep links. So do check that video out if you're interested in how to work with that. But yeah, I think that's it. I don't think I forgot to mention anything here. So yeah, we got to the end of the video finally. So in conclusion, we've covered the core aspects of Solana transaction encoding with a particular focus on the signing of, in the significance of Borsh encoding, which is it's a binary format that is super efficient, super optimized for this blockchain sort of use case with Solana. This is essentially for anyone building DApps on Solana. So we'll walk through practical examples like fetching and creating a user profile, which highlights how transactions basically flow through the blockchain and the wallet components. And we saw examples of reads and writes. So fetch the user profile to read, write is create user profile. And finally, in the last couple of slides, we've been looking at the specific details of creating the payloads to send to Phantom via deep links, following the Phantom documentation, serializing the transaction, receiving the serialized transaction, and then packaging it up with those send options that we discussed, so that the Phantom wallet knows exactly how to handle the sending of this transaction into the blockchain, and then what commitment level we want to get to confirm the transaction has been successful. So all of those things are part of how we configure the package that we're going to send via deep link into Phantom. And so looking ahead, so in the next video, as I said before, I'll dive into more complex examples of transaction encoding and querying the blockchain. There are a few more very interesting things that you will definitely want to know. Thank you for following along. I hope this presentation gave you a clearer understanding of the key components of how to encode a Solana transaction using Dart, and how to run a simple query to fetch the user profile. Even if you're using JavaScript, as I mentioned before, or any other language for client-side DApp development, most of what you learned here is valid and applicable to your language, other than the syntax, of course, which is different, but the steps will be very similar. The types of inputs required for each of the steps will be obviously almost identical. So I think there is a lot that you can take away from this, even if you're not using Dart. Also, as I stated in one of my previous videos, I'm going to repeat myself, but I think it's really, really important that you understand that, I personally, I wish I had all of this knowledge when I first started. This presentation is the result of countless hours of spent overcoming these various challenges and documenting these pain points along the way. As always, feel free to reach out with any questions or feedback in the comments below. I'm excited to continue this journey with you as we dive deeper into Solana's sort of amazing capabilities as a platform for DApp development. And yeah, stay tuned for more updates. Don't forget, as I asked in the beginning of the video, please like, subscribe, and hit the notification bell so that you don't miss my next video on this exciting topic of working with Solana transactions. Stay empowered, stay decentralized. Thank you very much. Goodbye.